Homeowners across Australia, any idea what is most likely your home's most energy-hungry appliance? The one single appliance that puts the biggest dent in your home's total energy needs. We're about to tell you. Due to Australia's climate, we tend to rely heavily on reverse cycle air conditioning for comfort. This can account for up to 50% of the home's total energy needs, making it the most expensive appliance to run. So with the number 50% in mind, consider this 30%. This is the amount of efficiency your system can lose in just a few years, making your system's energy consumption up to 30% higher. In this presentation, we will show you why this happens and how to overcome it once and for all. The culprit is oil fouling. Just as cholesterol affects the human heart, oil fouling has a similar effect on the heart of the AC system, the compressor. The compressor is the most energy-hungry component in an AC system. Let me explain how this works and why it's so important to have it repaired ASAP. In this area, heat transfer takes place. Heat transfer is what produces the hot and cold temperatures coming out of your vent. But what happens is here we've got molecules of oil that travel with the refrigerant through the condenser and the evaporator. The job of oil is to find metal and protect it against the effects of friction. Now that's great in the compressor where you've got a lot of mechanical movement, but in the condenser and the evaporator, you don't. So what does the oil do? It sits there on the tubes and it remains there. And this layer of oil fouling continues to grow over time. Here's the problem. The refrigerant's getting pushed through to conduct heat transfer to give you your temperatures that you want in your home. But here we're losing contact area because of what they call laminar friction. It's creating drag on the refrigerant. Therefore, the compressor on this end has to work harder and run longer to get to the desired temperature that you wish to have. Here's what oil fouling looks like in an AC system. It builds up over time, reducing efficiency and increasing energy consumption. Understanding the culprit is key to addressing and preventing it. Let's have a look now. Refrigerants pass through the condenser and the evaporator, and what we want is heat transfer to be produced to generate the temperatures. But it can't produce it efficiently because it's being dragged down by the laminar friction, meaning the compressor has to work harder to generate the result that you want. Remember, that's the cholesterol in the AC system. We don't want it there. ASHRAE, through decades of studies, has determined that the impact of oil fouling is very significant year upon year. The first year alone, your system loses about 7% of its energy and performance efficiency. Year 2, this increases to 12%. By year 3, you've lost up to 14%. Year 4, you're now looking at about 16% efficiency loss, and it continues thereafter. 18% by year 5, 20% by year 6, 22% by year 7, 24% by year 8, 26% by year 9, 28% by year 10, and up to 30% in just the first 11 years. Imagine what that does to your total energy consumption. EnviroTemp offers a quick and easy repair solution. The only tool needed is an injector and some EnviroTemp. Within minutes, the repair is complete, restoring your system's efficiency and reducing energy. EnviroTemp gets injected directly into the suction line, where within minutes it's dispersed throughout the system, removing the fouled oil, putting it back into circulation where you want it to be, and improving the system's efficiency. It only takes minutes. EnviroTemp has just been injected into the system and is now working its way through the heat exchangers. It's replacing the fouled oil with highly charged thermoconductive molecules, restoring efficiency and performance. We now have greater contact between the refrigerant and the surface of the tubes. This means your compressor is not going to have to run as long to achieve the results that you want. So you're saving considerable amounts of energy, you're achieving your comfort quicker than what you did before, and it will last for the life of the unit. Here's what EnviroTemp looks like when it enters a system. The molecules of EnviroTemp are circulated with the refrigerant in the oil. EnviroTemp molecules are attracted to the metal, dislodges the fouled oil, puts it back into circulation, and provides a permanent boundary of protection. We now have accelerated heat transfer. We're getting higher velocity here. You're getting better output temperatures, which I'll show you soon, and the compressor is working less to achieve the result that you want. Let's look at how an AC system with oil fouling behaves in a home environment. So right here, we've got our home. We've got our temperature control panel here. Let's set the temperature at, let's say, 22 degrees. Let's activate the air. Air is now coming out of the vents. Let's load up some data points that we want to measure. And let's get our infrared temp gun to take a temperature reading. And we're taking a temperature reading from a vent now. And out of the vent, the system is producing 12 degrees. Now, you look here at 22 degrees on the control panel. Setting 22 there doesn't tell your AC system that you want 22 coming out of the vent. The temperature coming out of the vent is the absolute best your system can possibly produce. Now, bear in mind, it has oil fouling, and it's only able to produce 12. The better the temperature, the quicker the system achieves what you want, and the system can cycle off and save energy. But now we're at 12 degrees, 67% humidity. The system's not running as efficiently as it could be, so it's unable to remove as much humidity. It feels like 24 degrees. It has reached 22 in the room now, and the system is about to cycle off. It took an hour and 15 minutes to achieve that result with oil fouling. Let's now look at an example of how an AC system without oil fouling behaves in the same home environment. So what we're going to do here is we're going to turn our system on again to 22 degrees. Let's load up the air vents, get them circulating, get our data points that we want to collect information on loaded up. System's been running for a while now. It's reached temperature. Let's see what's coming out of the vents. Now we're getting 9 degrees. Because we removed the oil fouling, the system is able to produce better heat transfer. That means the result it can now achieve is about 3 degrees better than what it was before. That's 9 degrees. Because it's working more efficiently, it's able to remove more humidity. Now it's down to 51%. And it feels like 23 degrees. How long did it take? Well, to achieve this result, the system now only had to run for an hour and 2 minutes with a 25% temperature improvement. What this means is a couple of things. One, because we're able to reach the set point temperature that you desired here, 22, quicker, an hour and 2 minutes, you're saving on energy. The other benefit is that now it feels like 23, whereas before it felt like 24. So if you adjust your temperature to match the comfort that you once had, which you're comfortable at 24, say bump this up to 22, from 22 to 23, you're going to save an additional 10% on your energy. Do nothing, and this result here is probably going to equate to about a 15% reduction in energy. Adjust the temperature to match your comfort by 1 degree, let's say, and now all of a sudden you're getting closer to the mid-20s. Thank you for watching. If you have any questions, give us a call or send us an email. We'd love to hear from you. Have a great day. Cheers.